Hello everyone. In this video I would like to prove the product rule. Like I promised in the previous video, I want to talk about the product rule only, and then in the next video I'll talk about the quotient rule. So here is what the product rule says of differentiation. It says that if f of x is equal to the product of two functions m of x and n of x, then f prime of x will be n of x times the derivative of m of x, m prime of x, plus m of x times derivative of that. So we differentiate this multiplied by that, and then differentiate that multiplied by that. That's basically what we call the product rule. Now, how do we prove this? By using first principles. We prove it as follows. I'm going to be a little bit slow so that you don't miss or fail to understand one step. So proof, we know that f of x is equal to m of x times n of x. Therefore, we can say that f of x plus h will be equal to m of x plus h times n of x plus h, like so. Let's go to the formula then. We know that f prime of x is equal to limit as h approaches 0 of f of x plus h minus f of x all over h. Moving into the next step where I substitute this information, we're going to have limit as h approaches 0. That expression now is going to be m of x plus h times n of x plus h minus the product m of x times n of x. I've decided not to put brackets there because it's simple product, all over h. Now, what then? Where do we go from here? We introduce what we call a special zero. I'm going to show you what that one is. A special zero. So I'm going to leave some space and move a bit down there and move back a little bit to that space there, is equal to limit as h approaches 0. And I'm going to put the special 0 in there. So please take note of m of x plus h times n of x plus h. And there, here is the special 0 minus. I'm going to multiply this one here. I'm going to multiply that one by that one. Multiply these two, add and subtract. So we have n of x plus h times m of x, and I must add the same expression, n of x plus h times m of x. So that is your special 0 right there. So I'm going to do this one here. We normally call it the special 0 in differential calculus, because that's basically 0. But remember, we have minus m of x times n of x at the end there. We're dividing the whole of this expression by h. So please take note, multiply those two, add and subtract, or subtract and add. Now you notice there is common factor in the numerator now. So I'm going to say this is going to be equal to limit as h approaches 0 of the common factor of these two terms, that one and that one. You can see the common factor is this guy here. So I'm going to say n of x plus h, and then I'm going to use square brackets here. Allow me to do that. I'm going to have m of x plus h, that term, when you divide in here by that, you're going to get this, and then minus, dividing this in there, you're going to get m of x. Right, and then there's a plus sign here, plus. Again, there's a common factor there. You can see the common factor. What's the common factor? M of x. So we have m of x, and allow me to use a square bracket there again. I'm going to have, when you divide m of x into that, you're going to have n of x plus h minus, divide m of x into that, you're going to have n of x like that. And we're dividing the whole of this expression by h. Now, there's something interesting here now. So what we need to do now is to check the limit as h approaches 0 of this, of that expression, and of that expression, and that expression. And of course, with h down there, we're going to use what we call term-wise division coming up again. So on page 2, if I go there, up there, and I'm going to say, on my page 2, I'm going to say, let me move this up, right. I'm going to say this is going to be equal to, check one step at a time, limit as h approaches 0 of, take h up, if you like, n of x plus h times m of x plus h minus m of x all over h, and I'm gonna use that bracket there plus, of course, if you allow me to use curly brackets there, take h up using term-wise division, m of x, and I'm gonna use square brackets there. We have n of x plus h minus n of x all over h, like that. And there you go. Now the h is gone. Now we're gonna take one term at a time. Here, this limit, we know limit is a linear operation operator. So we're gonna go find limit as h approaches 0 of that, of that, of that, and of that. So this is gonna be limit as h approaches 0 of n of x plus h, and then there's multiplication here, remember. So we're gonna say times limit as h approaches 0 of, take note of this, m of x plus h minus m of x all over h, and then we're going to say plus limit as h approaches 0 of m of x times limit as h approaches 0 of what? Of n of x plus h minus n of x minus n of x all over h, like this. Now as h approaches 0, this will approach n of x. So what do we have now? We're going to have n of x. This one here, if you remember from first principles, the definition, that will be m prime of x. And then I have plus. This is unaffected by h because you don't have h there. So as h approaches 0, this remains m of x. And that part there, you can see that as h approaches 0, this is basically the definition of n prime of x times n prime of x. So this is the proof for the product rule. Quite short. Will come again with another video where I'm going to look at the quotient rule. Take a pause and then come back with chain rule, and then look at differentiation, like I said last time, from grade 12 all the way up to university. Now, do not forget the special zero over here. The special zero, very famous. We have a special zero in the product rule, and then we have a special zero and special one in the quotient rule. So there you go. Simple definition from here. That is all by applying the definition of f prime of x from first principles up to there. But we had to create a special zero there so that we can separate the terms and obtain what we are looking for, which basically is this part here. It comes out so nicely like that. And remember, from the beginning, we said, if I may have both of them on the same page here, so to speak, we have, it says, if f of x equals m of x times n of x, then f prime of x equals n of x times m prime of x plus m of x times n prime of x. And that's exactly what we got here. N of x times m prime of x plus m of x times n prime of x. So that is the product rule. They do require you to prove this in calculus A and sometimes calculus B as well. So have a look at this, try to go through it and try and prove it. Yeah, you will enjoy it. All right, I'll see you in the next video.